streams in the next few weeks coming. Now for today's topic, we're going to do the measurement topic, which is perimeter, area, volume, all these kinds of questions that we have. We might later on, especially for the excellence questions, have some algebra being mixed in. And yeah, so basically every week we're going to be doing one topic that will set you guys up with some achieve, merit, and excellence style questions each week until the end of the year, so that you guys have some practice until the exam. All right, let's have a look. So first of all, if the fundamental questions that we're going to do are too easy for you, you guys are welcome to mute the stream, leave it running, come back in 15 minutes and check back, because of course we're going to start with the very easy questions, the achieve questions and the basic fundamentals of the topic. For people watching on YouTube later, afterwards, of course, there will be timestamps, so you guys can skip forward now. Okay, just a quick reminder, how can you guys benefit the most from this video? Well, make sure you guys are prepared. You've got everything with you that you need to do some math. It's very important that you guys do math, not just listen to mathematics being done. That way you guys are more likely to remember a lot of the topics and concepts. And yeah, also the chat is live. So if you guys have any questions, it doesn't matter how many questions you guys have, put them in the chat and then we can go from there. All right, let's start with the first part, the very basics, which is the perimeter. Now for the perimeter, all we do is we add all of the sides together. This is one of the easiest parts of this topic, and we can zoom through some of these examples. I just want to note that when you do these kind of questions, that you always make sure that you have the same unit for all of these. If you don't, you need to make sure that you change them into the same unit. So first of all, here we have ourselves a trapezium. If we want to find the perimeter, we're just going to start at one end and we're going to add all of these sides one by one. So we're going to get 20 plus 13 plus 15 and plus 12, all the way until we're back at where we started. And we're going to put that into the calculator if you have one. So it looks like we have here 13 and 12 makes 25, plus 15 is 40, and 20 is 60. All right, there we go. So we have 60 as the perimeter. And of course, don't forget your units. Let's have a look at this example over here. All of them are in meters. So for the perimeter, we can just add everything together. We have 1000 plus 600 plus 800 plus 600 is equal to, and that probably would be 2,200, 3,000, if I'm not incorrect, meters. All right, so here we have a hexagon. We've got 6 sides. So again, if we're asked to do anything with the perimeter, we're just adding all of the sides together. So we have 200. You don't really need the units until the end of the question. Plus 200 again. And then we're going to get plus another 200. So we have 1, 2, 3 sides. Then we're going to add another 200. Then we have 150. Did I miss one? Did I do one too much? 1, 2. So we have 200, we have 300, another 200, 200, 150, and this should be, I think, 300. Oh my god, we have 1, 2, 3 200s. There we go, 200s. And then we have 2 300s, and then 150. And you guys can easily put that in the calculator and see what you guys get for the answer. These are all together 600. Then we have another 600 here. So we have together 1,200, 1,350. And then, of course, the unit. Okay, and this is the only part for perimeter that you guys need to remember. That is a little bit different when you have anything with a circle. When you have the perimeter of a circle, it is called the circumference. And this is basically just a different term for the outside part of the circle. Now here to find the perimeter of this shape, again, we're going to start somewhere and we're going to go all the way around the shape until we're back. So the first part here is this kind of half circle of the outside, so the circumference. So we can have a look. The circumference is 2 pi r. This is a formula that you are given in the formula sheet. So you can use this one very easily. All we need the radius. Let's have a look. What is the radius here? We have 24 here. That is the diameter. So the diameter is 24 centimeters. And the radius is always half. So we have radius is 12 centimeters. So we can now put that into our equation. We have 2 pi times the radius. But of course, we need to multiply it by a half because that is just half a circle. We have a semicircle. And then we have to add the 24 afterwards. So let's substitute that in. We have 2 times pi times 12 times 1 over 2 plus 24. And we can put that in the calculator. And because we have a pi, can't really calculate that very well. So let's have a look. I'm going to go to the calculator. And we're just going to type in exactly what the formula says. We're going to get 2 multiplied by pi. Pi is shift times 10. There we go at the bottom. Times 12 times half. And we're going to add 24 at the end. So we get 61.7. So we have 61.7 and then the unit centimeters. All right, and that's already basically the first part done, the very easy part, which is everything to do with perimeter. I just want to note that sometimes when you do these kind of questions, they're not going to be as easy. You're going to get some questions that involve some algebras or algebra expressions. So let's have a look here. If we want to find the perimeter of this shape. Now, just because we don't have numbers, everything is still the same. We pick ourselves a point and we're going to go around the shape and add all of the sides together. So we have 2x squared over here. Then from here to here, we have 3xy. And for the last part here at the bottom, we are adding 4y. So plus 4y. And for these algebraic questions, all you got to do is make sure that you simplify at the end. But of course, in this case, we have an x squared, an xy, and a y term. So they're all different like terms. We can't simplify these anymore. Okay, I mean, that's already the first part done, the easy part, which is the perimeter. Now, when it comes to area, there's one thing I want to note here. This is a copy of the formula sheet that you had in 2023 and in 24. And I assume that the 2025 formula sheet is going to be exactly the same. They usually don't change them up that much. So if we have this here, hi Eric, how are you doing? Yeah, so if you guys have these kind of questions with measurement in your end of year exam, you can always refer back to this formula sheet. And I want to note here that when it comes to area, we have triangle, parallelogram, trapezium, and the circle. These are your 2D shapes where you have the formulas available. And there's a couple missing. I would assume that you know these already. I'm just going to make sure that you are aware. So for a square, the area formula is squaring one side. And for a rectangle, which is assumed that you know, the area is base times height or length times width, whatever you want to call it, one side times the other. These are the two formulas that you need to remember by heart, but everything else you can look at the formula sheet. Okay, we're going to get through some of the questions for the volume a little bit later. So let's have a look here. Whenever you do any kind of questions where you have a shape and you want to find an area, the first question is always, what is the shape? Because then you can check out the formula for it. So let's have a look over here. So we have a triangle. So we go to our formula sheet and we have a look. So we have half times base times height, which is over here. And it's actually really good because they give you the information that the height and the base here have to be on a right angle. So we can just copy and paste our formula, which is half times base times height, exactly like the question is telling us from the formula sheet. And then we just put in all of our variables, our numbers. And just like the formula sheet has presented to us here, we have this one here being the height. And then we have this here, the base. Why is that? Because every time when we have these measurements, the height and the base need to be on a right angle. So if we substitute these numbers in, we have half times the base is 24. The height is 16. And we can put this in the calculator. So let's do that right now. We're just going to go and type in half times 24. Oh, it's not typing. Half, yeah, there we go. Half times 24 times 16. And we get 192. 192. And then don't forget the unit. So here we have centimeters. And of course, it's area. So we need a squared. Okay, next question over here. Let's have a look. First of all, we ask ourselves, what shape do we have? And of course, we have a trapezium. How do we know? Well, we have two sides that are parallel. That is the requirement for a trapezium. So we can go and have a look at our formula sheet. And it says over here, a trapezium has the formula sheet half times a plus b times h. Sorry, half times a plus b times h. And what we can do is we can double check where these a, b, and h are. Again, the h is going on up here on a right angle to the base. And a and b are the two parallel lines that a trapezium has. So knowing that, what we're going to do is copy and paste our formula. So we have area is equal to half times a plus c times by h, the height. So once we have that, we're just going to identify where our parts are. So here are our lines that are parallel. So there we go, 1 and 2. So we're going to get that A is 40 and B is 30. It doesn't actually matter which one you pick. You just randomly pick one as A and one as B. And then the other part is we want the height, which is measured through here. But of course, that is this one here. It's not the 26 because the 26 is not on a right angle. We need the height to be on a right angle. So we get H is 24. Okay, so what do we have? We have a formula. We have numbers for it. So we're just going to replace them, substitute them in. So we're going to get A is 30. C is, A was 40, my bad. B is 30. And then H is 24. Sorry, I usually always remember the formula by having A plus C. But that's okay. We're going to go with the exact formulas that you guys have in the formula sheet. Now, do remember that here between the number and the brackets is always a hidden times, yeah, because in the formula we have times by h between variables and brackets as a times. So again, we can put this in the calculator. We get half times 70 times 24. So let's get our calculator out and we're going to type that in. We're going to get half times 70 and then times 24. And we're going to get 840. So we have 840 in unit centimeters and again squared because we have an area. Okay. This is an example that we had just before as well, just a little bit of a different measurement, I suppose. Now, if we want to find the area, again, it's a 2D shape. What do we do first? We first check what is the shape. We have a circle. So we can write down the area formula for a circle. So if we have a look at our formula sheet over here, here we can see the formula for a circle. And we have the circumference, which we used before as 2 pi r, and the area is pi r squared. And if you forget where r is, well, they give you a nice little picture here to remember that r is the radius, and d here is the diameter. So if we now have a look at our question, we can copy our formula, which is pi r squared. But then this is just the formula for a circle. We need a semicircle. So what are we going to do? We're going to divide it by 2. So this is our formula for the area for a semicircle. So what are we going to do? We're going to find out all of the variables that we need. So that's the radius. We know that the diameter here is 12 because that is the line going from one side to the other through the center of the circle. And the radius is always half. So we're going to get to 6. So we can add those numbers in our formula. We're going to get pi times 6 squared all over 2. 6 times 6 is 36. So we have 36 pi over 2. 36 halved is 18. So we get 18 pi as our answer. And if you are in a real life situation, you should probably change it from pi into a real number. So we're going to do exactly that real quick. So it's 18 times pi, and we have a pi here at the bottom. If you don't have it, they also give you in the formula sheet that pi is 3.14, I think 1415. That's what they give you in the formula sheet. So once we have that, we can give our area as an estimate of, supposed to, of course, click the change button to decimal. So that's 56.55. That's 2 decimal places, centimeters squared. Okay, and with this, we already have the 2 easy parts. So we've got perimeter, we've got area, and these should be very familiar to you guys. I would expect that majority of you guys know how to do these very well. So we're just going to go through one more thing, which is the volume as a fundamental, and then we're going to have a look at our achieved style questions. For volume, again, there is some formulas in here, yeah, and the very basic one here being a box, yeah. Remember, this can also be used for a cube. It just happens that the height, the height, width, and length are all the same number. There's not really much I need to say about this besides one point, and that is something about this part here at the top. We have a lot of students that always struggle with prisms, and that is because they are a little bit harder to identify than the other shapes. Now, we know a cylinder when we see it, a sphere, same thing, or a pyramid. What makes it difficult here is the first part, which is the prism, and a cylinder is kind of a prism too. We just have cylinders very often in life, so we use that formula very regularly. Okay, let's have a look. If we're going down and having a look at the prisms, I've actually got you guys a few photos of different prisms. And there's one thing that you guys need to remember. So we need, in order to see if we have a prism or not, we need the height, as always, on a right angle. Oops, there we go. That's a bit nicer. Okay, what does that mean? Well, all the prisms always have a base area, which is a 2D shape that we already know. So for example, in this one here, we have a pentagon. That's our base shape. And now we can see on that base shape, we have a height. So these are lines that are on the base on a right angle. So we have a right angle here for all of these. Now we know that this here is the height of the prism, and this is the base area of the prism. And as long as you know which one is which, you can use the formula that they give you. The one part where it's confusing sometimes are, for example, the trapezoid. So let's have a look at this one here. More specifically, a lot of students always think of height as this part, how high this 3D shape is. But that's not correct here. The reason why is because the height has to be on a right angle to the base area. Now, the base area is the one that has all of the lines going on a right angle from there. So the base area here in the front is actually the trapezium here in the front. And then from there, all of the lines here are on a right angle to the base. So you can always think of prisms as a shape that has to stand on its base area, and then whatever the base area is, it has to go straight up from there. So if the sides don't look like they're straight up, then it might not be a prism, or the prism is on its side. So you have to think about how that prism works. So let me get rid of this. Yeah, there's another prism on here that is not on its own base area, which is the triangular prism here. And we can see here which part the base area is by checking out the parallel lines. So here, these three are our parallel lines. So that means we need to have those standing up. Then we can see what the base area is. So if we flip this to kind of make these lines go up, then we can see that the triangular part here in the front is actually the base. That's what it will be standing on. So when we talk about the base area of a prism, we always mean that area that we have in front. You can also think of this as a cross section. And I think that's how they have put this in the formula. Yeah, we have a volume for a prism is the area of the cross section, or the area of the base, times the length of the prism, yeah, or the height of the prism, however you like it. Okay, and in that sense, of course, the cylinder is a prism as well, with the base area just being a circle. So let's have a look at a couple of easy questions before we start exam-style questions. Just to get everyone warmed up for volume. Well, here we have a cylinder. I don't know why we have an AL there. There we go. So, did I say cylinder? We have a cuboid. So, what is the formula? Well, in the formula, it says length times width times height. So, we're just going to copy exactly what is in the formula sheet so you guys can use that. Now let's have a look. It doesn't really matter which is the length, width, or height, so we can just multiply them all together. So we have 1, which is 12 millimeters, multiplied by 16 millimeters, and 32. There we go. And again, we can use our calculator for this. So we can have a look. We can do 12 is multiplied by 16, multiplied by 32. Why does it always do that to me? Yeah, there we go. It's working. 12 times 16 times 32, which is 6,144. And we're going to put our unit. And now this time it's a 3 because we, of course, have volume. Okay, next part. Well, let's have a look at this part here. It looks kind of like a ramp. So if we want to know the volume here, how can we do that? Well, for these questions, we always need to figure out what kind of formula do we need. And here what I see is we have 3 lines that are parallel. So it looks to me like this is a prism. And if we now move this around, we flip it around this side, so it stands on this triangular area, then we can see that yes, all of those lines go straight up. So we have indeed a triangular prism here. So what is the volume formula for a prism? So we have the area of the cross section times by the length of the prism. And that is exactly what the formula sheet gives you guys. So let's put our variables and our numbers in. What is the area of a cross section? And here we just kind of have to think about what do we have for an area that we have on our base. Well, we have a triangle. So the area of a cross section is replaced with the area formula for a triangle, which was half times base times height. And then, of course, we're still multiplying by the length of our prism. So what are we going to do next? We're going to have to find out what the base and the height are and what the length of the prism is. Well, if we have a look at the triangle, the only thing you need to remember, base and height are always on a right angle. So we need to check out where's the right angle. There we go. We have a right angle here. And then it doesn't matter which one is the base and which one is the height. So let's say the base is 12. The height is 5. And now we just need to find where the length is. And the length of the length of our prism here is those parallel lines. Hey, how are you doing today? Welcome to the stream. Okay, this here is those parallel lines and they're all the same. So we have 9 millimeters for this. So we have the length is 9. Okay, so let's put our numbers in. Half times the base is 12. The height is 5, the length is 9, and we've got everything that we need. So let's again chuck it in the calculator and we're done. So we have half times 12 times 5 times 9, which is 270. And again, our unit, millimeters, but cube because we have volume. Okay. So there's one more question here that I will leave for you guys as an exercise. You guys can either pause the video for a bit later or come back to it later. If you want to find the volume of this shape over here, all you got to do is figure out what shape we have and then use the formula, just like we've done before. Okay, so now we have gone through the fundamentals, which was how to do the perimeter of 2D shapes. We have done the area of 2D shapes. We have done the volume of 3D shapes. The one topic that I didn't talk about here is the surface area for 3D shapes. And basically, with everything that we've done already in the fundamentals, that is something that you can do very easily by yourself. There's nothing new to this besides the fact that you need to know what the surface area means. So if you have a 3D shape, the surface area simply means adding together. So adding all faces. Yeah, so we're adding all of the little 2D shapes together, and that's all we need to do. It might be a little bit longer. Yeah, there might be a lot of work here that you need to do because you need to find out all of these separate parts. But from there, you can easily just add them all together. Let's have a look at the shape that I've kind of drawn here. If we are told that this is 5 centimeters, this is 10 centimeters, our height is, let's say, 15 centimeters. And we might need, we might need the slant as well. Let's say this is 8 centimeters. I'm just making these numbers up just to showcase. This probably won't actually exist just like that. The numbers are not going to work together, but it's just to showcase what we would do. So we would have this kind of rectangular shape that we have over here. That is one of the faces. So we're going to have to find the area of that rectangular shape. So area of a rectangle. And again, we know it's base times height or width times length, whatever you like. And here we have 10 and 8 as our side length. So it's going to be 8 times 10, which is 80 centimeters squared. And then we're going to have a look at the front here, which is this part here. This is the triangle. Yeah, so we need to use our formula for triangles. We've done that already as well. So it's not like there's anything new here. It's just more work. So we're going to get half times base times height. Well, and the base of this triangle is 5 and the height is 15. Why do we have that? Because remember, we need to have a right angle for our height. So that's this part here, which is the 15 that I gave you guys on the side. So let's have a look. How much do we have here? Let's put it in the calculator and let's go from there. So we have half 0.5 times 5 times 15 gives us 37.5 centimeters squared. Yeah, that's actually correct here in the chat. So the question was for everyone watching this later. So you calculate all the sides by multiplying them, then adding them at the end. So by the way that I understand your question is we find all of the sides first, and then we're adding them all together, just like when we did this with the perimeter. So at the moment, all I'm doing is I'm going through all of the sides that we have, left, right, in the front, in the back, and the bottom, depending on the shape. And I'm just going to list them, and later on I'm going to add them all together. And these numbers here, they're multiplied because that's what we got from our formula sheet. So we had base times height for our triangle. We got this back from there. And then we have the rectangle, which is the one that you guys need to know by heart. Okay, so we have ourselves this side here. We have ourselves got the front here. Is there any other shapes that we can see? And you kind of just have to look through and go side by sides. No problem for that answer, no worries. So here at the bottom, we have one last shape, which is another rectangle. You might have to look a little bit harder on how this shape goes and rotate it in your head so you can kind of see what shape we have. But then we have one more area to find, which we can do here. And let's call this the area of the bottom. And again, what shape do we have? Always ask ourselves, what is the shape? We have a rectangle. So let's write down the formula, base times height or width times length, whichever one you like. And then substituting in our numbers, and I'll do it next to it so it doesn't, so my face is not in the way. There we go. And we can see one side is here 10, the other side is 5, and they are on a right angle because it's a rectangle, so that's perfect. So we have 5 times 10, which is 50 centimeters squared. And now what we need to do is we need to put all of those together. And we're kind of just looking at them one by one, but I mean, some of them will be there repetitive, so we can use multiplication, but just to keep it very simple, we're going to go through the picture, we're going to add them one by one. So first I'm going to start with the front. There is a triangle in the front and there's the same triangle in the back. So I'm going to add those two to my surface area. And we have already calculated them one by one. So we're going to have 37.5 plus 37.5 because those are the two triangles that we've got. Now what other parts of this shape do we see? Well, we had this long rectangle that's kind of building like the shape of kind of like a house, like these parts of the triangle or of the prism. So those two we've already calculated right in the beginning, which was this number here. And we have one on the left-hand side and one on the right-hand side. So we're going to add both of those together. So we have 80 and another 80. And now there's just one more side that's missing, which is the bottom. And we've calculated that here at the end, which was our 50. That's this part here at the bottom. So we're just going to add that to our surface area as well, which is going to be 50. And next part, we're just going to calculate, and that is the end of our question for surface area. So surface area itself is not necessarily more difficult than what we've done in the fundamentals, but it's a lot more work. So let me just quickly type that in. So we have 37.5, we have that twice, then we have plus 80, and we have that twice, and then plus 50. There we go, which should be 285. And again, unit 285 centimeters squared. Now, when it comes to surface area, it's literally just work of working out all the sides, working out the measurements. And what I recommend is always one by one, writing them all down and tell yourself what you're calculating. It doesn't have to be pretty. We didn't make it very good for the reader here. It's just for us. So we know what we've got. We've got the side pieces. We've got the area of the triangle. And when we ran out of shapes, we used the other one and we called it the bottom, because that's what we kind of saw it as the bottom. And then we go back and add them all together, just like when we did the perimeter. And that's all. That's all you need to do for surface area. We're going to have, I think, a couple more questions with surface area a bit later. But that kind of completes all of our fundamentals from perimeter, surface area. We had the area, and we have volume for 3D shapes. Now, for the end of year exam, it is very important that you guys remember that this is a combination of topics. So it's a 3-hour exam that you guys have, and there's lots of different topics that I've put up in the beginning. All of these questions that we're going to go through will have some of the topics in there mixed. And if you feel that some of these you're not really that good at yet, for example, the algebra parts, don't worry. Remember, I've blended in the beginning which date we're going to be doing all of the other live streams every Sunday, 3 to 5. And we're going to go through all of the topics and then do lots of exam preparation questions. Yeah, I'm glad it's helping. I'm glad it's helping. Very good. Yeah, keep letting me know in chat what you guys think. If you guys have any questions, then we can go through a lot more personalized questions for you guys. Okay, let's have a look at this achieved style question, which is actually from one of the past papers of the reworked 1.4 mathematical modeling. Now it says here the perimeter of the rectangle shown below is 56 centimeters. And we have our length and width given, but of course we have in terms of algebra. So we have here this and this, even with unit. Now it's asking us to form an equation and solve it for the value of x. Now the solving part is kind of the algebra part, but that's okay. We'll complete the question and that will be in depth covered in our algebra topic. But let's have a look here. This question by itself is just asking for a perimeter. So if the question is talking about perimeter, all we're going to remember is we go back to the fundamentals. What is the perimeter? The perimeter means we start somewhere on the shape, we go all the way around it until we're back. So let's just pick this place here as our start. And we're going to go all the way around until we're back. So let's first go over here. Well, we need to write down how long this side is. And of course, because it's a rectangle, we know each side is the same length. So we get 3x minus 5. And they're very kind here to give you that these are in brackets. If they don't have brackets here, then you need to remember that each one of those itself has to be put in brackets. It says, I just have a question. Have you done a stream of numeracy exam and NZQA like covering it? So for the numeracy, I would assume that you're meaning the new numeracy co-requisite that is required, which happens often in September and in May. I don't think I have specifically done a video on it, but it is in the works. So there will be a video where I go through past exam questions and we kind of just go through them. Yeah, I'll kind of also structure them into 3 videos. That's kind of how I like to do these kind of videos in the future, where I have some questions with achieved, some merits, and some excellence parts. Okay, let's have a look at this question here again. So we had the 3x minus 5 side. Then we're going to add the next side, which is 2x plus 3. And again, I prefer if you guys put brackets around it. And then the next part here is this one over here, 3x minus 5 again. And then the last one is 2x plus 3. And we know parameter, we know how it works. We add everything together. Oh, sorry, I need to scooch over a little bit. There we go. We add everything together and then we just calculate what we have. Well, here we have a bit of algebra. So we just need to remember here, if we forgot from algebra, that all of these are different like terms. When we're adding things, all we care about is like terms. The first part here is we have nothing in front of the brackets, no multiplication, so we can just drop all of these brackets. Technically, there's a plus 1 in front, and if you expand 1 times everything else, it's just going to stay exactly the same. So we can just get rid of all of our brackets, which is the next step that I recommend you guys doing. Always getting rid of the brackets first, because sometimes there can be some nasty negatives together. So what else do we have here now? If we want to solve this, remember in algebra there's like terms, so we're going to get 3x, 2x, 3x, 2x, and then we're going to have our numbers that don't have an x. They are also like terms, and now we can just do them one by one. So if we do 3x plus 2x plus 3x plus 2x, we just add them together by adding the numbers in front, and the x stays the same, the term stays the same. So we get 3 plus 2 plus 3 plus 2. Hopefully that should be 10. There we go. That's all of our yellow terms done. And then the blue terms, we're going to get minus 5 plus 3. And that again twice, so that should be minus 4. Also, if I talk a lot and I write at the same time, it happens that I make mistakes. So if you guys see some silly mistakes, please do let me know, and we will fix them immediately, of course. Okay, there we go. That is the finished part 4 achieved. Yeah, we've just done the measurement part to get to our perimeter. Yeah. Now the question is telling us one more thing, and that is that the perimeter is 56. So here, even though while we calculated this part here, the perimeter is 56. So we can keep that along the whole time when we substitute in. So now we have an equation with one unknown variable, which is x. We can solve for x. We don't need anything else anymore. So let's just focus on solving this equation. We know that once we solved it, we've solved the question. So how do we do this? We want the x. So what is in the way? We have a 10 in the way, and we have a negative 4 in the way. And if you guys forgot, when we're solving questions, we need to go backwards for BEDMAS. So here plus and minus are the ones that we do first. So what do we have to do? We need to get rid of the 4 by doing the opposite. So plus 4 on both sides. So 56 plus 4 is 60, is equal to 10x. And these two, they go away. They are technically 0, but I mean, it makes sense for them to go away because that was our idea. We wanted to get rid of them. That's why we did plus 4. And now lastly, we have one more thing that we need to get rid of to have an x by itself. We want x by itself, and that is to get rid of the 10. And always remember that here, when we have 10x, that is the same thing as 10 multiplied by x. There's always a sneaky times in between numbers and variables, also numbers and brackets, and also variables and brackets. So how do we get rid of a times by 10? We do the opposite. So divide by 10 on both sides. Get 6 on the left-hand side, and on the right-hand side, we get x by itself. Okay, and there we go. That is our answer. And we finished our first question. Okay, let's have a look at the next question. So Make it a little bit bigger. There we go. We have the rectangle and the square shown below have the same perimeter as each other. Find the value of x. So again, that question is telling us we need to work with perimeter. This is also a past exam style question, by the way. So let's have a look. If we want to know the perimeter, we need to write down what that is. So let's start with our rectangle on the left-hand side. So we're going to go the perimeter of the left rectangle. And well, how do we do that? Again, we pick a point and we add all of the sides that we have together. Well, the top side over here, and I might just mark them like this, the top side over here is 3x plus 2. Then we have 2x minus 5. Then at the bottom again, we have 3x plus 2. And on the side here again, we have 2x minus 5. And as I said before, I prefer if you guys add brackets around every time you guys take a whole piece of algebraic terms. Now, what do we do with all of these? We add them together because that's how we do a perimeter. We add all of the sides together. So if we now have a look here, now we don't need any of our brackets here because there's just a plus. There's no negatives, there's nothing else, but you can think of this as a positive one again, multiplied by each term in the inside. So I'm actually just going to take away all of our brackets over here. That should do. We don't have to write it again. And in algebra, just like before, we have to collect like terms. Like terms means they have the same letter or the same variable. And here these numbers here they don't have a letter at all afterwards, so they are their own type as well. So adding them together, we have 3x plus 2x plus 3 plus 2. Is that kind of the same as we had before, is it? So we're going to get to 10x minus 6, if I'm correct. So it's a little bit different than the question before. Yeah, it was different. Okay. All right. Next question. 1 second. Oh, why is this doing this? There we go. Okay, next part. Okay. Now we have ourselves got the perimeter of the left shape. Now we're going to do the perimeter of the right shape. So let's have a look. Perimeter of the right shape. How do we do that? Well, we add all of the sides together and we have a square here. So we're going to get 6. Well, and we have 4 sides. So 6 times 4 is 24 centimeters. Oh, it doesn't really have units. So let's just say 24. Now, what is this question actually telling us? We have got the perimeters because it's talking about perimeters. The next part here is saying it's the same. They have the same perimeter. So what that means is that one of the perimeters is the same as the others. Yeah, so we have the perimeter from the left is the same as the perimeter on the right. And now, since we know both of those, even if it's an algebraic expression, we can just replace them. The left one, we had 10x minus 6, and the right one was 24 that we've calculated over here. And now, what do we have? Again, we have an algebraic expression that we can solve for x. So we're going to do plus 6 on both sides, which gives us 10x is equal to 30. And again, we have a 10 multiplied by x, so we're going to divide both sides by that 10. So we're going to get x is equal to 3. And that is our answer. All right, there's a couple more achieve questions that I would like you guys to do. So if you guys are watching this from home, make sure that you guys are pausing the videos at these and giving these questions a try. We're going to come back to some of those questions a little bit later, depending on how much time there is left, but we do want to make sure that we get some achieved and some mirrored questions as well as the excellent questions in. Let's have a look. Yeah, let's do this as our last achieved question. Okay, let's have a read. We have a 6-pack of bowling balls that need to be transported from one bowling center to another. The box they are stored has a height of 30 centimeters. So what I recommend to everyone is, as soon as you're reading your text question, stop every single time when you have information and make sure that information is clear with a picture. So we have a height over here of 30 centimeters. Now it says there's no gap between the box and the bowling balls when stored completely. So they're all like tight next to each other, right? So if we look at this from like a bird's eye view, all of the balls are kind of like, there we go, like this, all touching each other. Perfect. Okay, now A is find the volume of the box. Well, what is it asking for? Oh yeah, okay. It's just asking for the volume, so we need to have a look. What shape does this box have? Well, this shape is a cuboid. Yeah. So what do we need? We have length times width times height. As long as we figure those out, we're good to go. We've done question A. Let me add an A there in front. There we go, to make it clear. Well, and if we have a look at our question here, all we know so far is the height. Well, how can we figure out the other parts? So this part here and this part over here. Well, it tells us that those balls are not touching, are touching each other, which means we basically have one here. The next one is there. There's no gap between it, and there's no gap between the boxes. So we know that this is exactly 3 bowling balls to make the length. Also, we can see that one bowling ball is exactly from the bottom to the top. Yeah, that's our height. That's the 30 centimeters here. So this question is giving us that the size of this bowling ball is 30 centimeters in diameter. So how can we use that? Well, if we put 3 of those balls next to each other, that means we have 3 times 30, which is 90 centimeters for our length. And then we have one more over here, which is this part here. So if we want to do that, maybe we'll do that one in green, so it's a little bit clearer. Here we have this one in green. We know this already. So that's going to be 2 balls. So it's 2 times 30 centimeters, which is 90 centimeters. So now we have got the dimensions of the box. So we can just substitute everything into our formula, which is 30 times 90 times 90. Oh my God. Times 60. There we go. I did promise that when I talk too much and write at the same time, I will make calculation mistakes. There we go. Wonderful. Okay. If we put that into the calculator, let's have a look what we get. So we get 30 times 90, 60. Okay, we have 162 and then 3 zeros. 162,000. And what was the unit? The unit was centimeters cubed. Okay, there we go. We're done. We found the volume of the box, which is an achieved question. Now it's asking find the volume of the 6 bowling balls. Well, let's have a look. We want the volume of the 6 bowling balls. So we first need to find the volume of one ball. Yeah. So this is the volume of a ball. And again, we're going to go to our formula sheet and we're going to have a look what formula we have. We know it's a sphere. So we can go all the way back to our formula sheet, which was here. And we can see that the volume is 4/3 pi r to the power of 3. So let's take that on. There we go. Everything's on the screen. Very good. So we have 4/3 pi radius cubed. And now in order to figure out what this is, we need to find out what the radius is. Well, remember, we already have found out that the diameter is 30 centimeters. So how can we find the radius? That's half. So let's put that in. We're going to get 4/3 pi times 15 to the power of 3. And we can put that into our calculator as well. Let's do that. So we're going to get 4/3. You guys can probably use a fraction here as well, but it doesn't matter. Let's do 4/3 times pi, which is here in the bottom, and then multiplied by 15 to the power of 3. There we go. And we don't want it in terms of pi, so we can press the SD button to give ourselves an actual decimal, which is 14,137.1. Let's do 0.2. Let's just do 1 decimal place. Okay, wonderful. So that was the volume of a ball. So what do we need to do? The question asks us for the volume of 6 balls. So to get the full marks here, we need to multiply it by 6. So we're going to get 14,137.2 times by 6. And let's do that in the calculator as well. We already have the number before, so multiplied by 6. And we don't want it in terms of pi. So we get 84,823.0. Cool. Okay, so let's have a look. This is our part B done. And part C, it says find the volume of the air in the box once all the bowling balls are placed. So how do we find that? Well, we've already got the volume of the box itself. We've got the volume of everything that's inside of it. And then we just need to find the air, which is the difference between of them. Hi. Yes, I do the numeracy exam prep, but at the moment I don't have a video uploaded. I'm currently producing 3 videos which are covering the easy, the medium, and the harder style questions for the numeracy exam. So you can expect them within the next week or within the next few days, because I know there's a numeracy exam coming up in September, I think it is. When is your exam? All right, let's finish this last question over here. We are asked to find the air. So that is the volume of the box. Just like we said before, the volume of the air is the volume of the box minus the volume of the balls. So we're going to just put those numbers in. The box was 162,084,823 for our balls. 4th of September. Thank you for that. That gives me a time frame to make sure I upload some papers. Would you prefer me going through past exam papers and going through all the questions and explaining them? Or would you prefer if I make additional ones myself and upload those ones? Okay, let me just finish this question here. $77,177. All right, perfect. So that is now the air. Okay, this concept of calculating the air or something that's in between will come in very handy when we do the merit and excellence style questions. And if you guys understand how to do these ones here, then you will just be able to transfer that knowledge that you have to the next one, to the excellence questions. And sometimes the only difference is that they have some algebra in it. Okay, yes. Now, we've done achieved style questions. We have done the fundamentals. It's time that we tackle something a little bit more difficult. And I'm just going to blend this in for anyone else who is watching this later on, or if you guys are coming back to the video for practice, then this is another achieved style question where you basically just need to understand what the question is giving you and then going from there. Okay, this is another achieved style question with a little bit of algebra in it. This is actually a very quick one. Yeah, I guess we've got another hour to do merit and excellence questions. Let's do this one question for achieved style. So if you read this, remember as you read the questions one by one, look at the picture so you know what they're talking about. And when they give you more information than the picture actually has. So we have an isosceles triangle. Isosceles means we have two sides that are the same length, so that are the two y's. Has AB, which is 2x. A to B is here. Okay, that's in the picture. And then AC is the same as BC, which is y. Wonderful. That's perfect. Everything is in the picture. Now it's telling us the perimeter is 100. So again, what do? Every time we see the perimeter, the area or so on, we make a mental note of it, and that's what we're going to find. So before we even know what to do in the question, we know we have to find the perimeter. Well, I guess it's given to us, but we're going to have to use the formula for it, or our way of working. So it says the length of the perpendicular from C to the line AB. Perpendicular means it's on a right angle. Yeah, so the line that's on a right angle to AB is this line over here. That's this one here. I'll make it in blue. Is 10 centimeters. Also, that is included in our picture. So we can heavily rely on this picture helping us out here. Now it's saying find the length y, and this is from A to C. We know that. And give your answer in terms of x. And this is kind of one thing that a lot of students don't remember, and that is, what does it mean in terms of? Yeah, so in terms of x means we want to find a formula. Yeah, we want to find y, so we want to have y equals, and whatever we have here, this part here is allowed x's. So here we are allowed an x. It doesn't even matter if it's 3x, 5x, the square root of x, x to some power, everything is fine, as long as there we only have numbers and we only have x's. But we cannot have more y's there. All the y's have to be by itself on this side. So we want to find a formula for y, and we also have been given the perimeter here. So let's start with the perimeter because we know that was our first part. How do we find the perimeter here? We start at one part and we go across all of the three sides and add them together. So the perimeter is 100, but we can also start at A and go to C. That is going to be y. Then we go from C to B. That's another y. And from B to A, which is going to be 2x. So what do we get? We get ourselves a new formula here with x's and y's in it. So we get 100 is equal to 2y plus 2x. Now, in order to get the full mark here, it's asking us to find y. So we want to have this part here. So how would we solve for this? All we got to do now is solve this equation for y. Well, we have a number in front of the y that we need to get rid of, and we have a plus 2x that we need to get rid of. Remember, solving equations means base mass backwards. So we first have to do plus and minus. We have a plus 2x, so we do the opposite to get rid of it. So we're going to do minus 2x on both sides. So we're going to get 100 minus 2x. Remember, these are different like terms, so we can't combine them. We just add them next to each other. And then on the other side, we have left 2y. So now there's only one thing that we still need to get rid of, which is the 2. And remember, the 2 is multiplied by the y. So we do the opposite. The opposite of times is divide. So we're going to divide both sides by 2. And the important part is, and this is why I usually write this as a fraction, is that we're dividing the whole side. Yeah, you could also say this whole side here is divided by 2, and this whole side here is divided by 2. The reason why it matters is because on this side, we're not just having this one divided by 2 or this one, but we have both, the whole side. And if we do the right-hand side here, of course, the 2 cancels, so we get just the y. And on the right-hand side, we can actually just leave it as this exactly, because we don't care at all what this looks like. We're not asked if it's simplified. We're not asked anything except from we have a formula for y where x's are allowed to be in. So this is already where you can stop. If you really wanted to, you could split this in half because we have just a number at the bottom, and you can do 100 over 2 minus 2x over 2, and then we can simplify, but this is here not required. Yeah, so this is not required for a mark. You get your full mark for an achieved over here already. 100 divided by 2 would be 50, and 2x over 2, half of 2x is 1x, and we don't forget the negative, of course, and we're done. There we go. We have ourselves a very nice, simple equation for y in terms of x. Okay, it is time to up our game a little bit. We have just under an hour left to do merit and excellence style questions. I would suggest that we have at least 30 to 35 minutes for the excellence questions because they do take a little bit longer. So let's have a look. What kind of question can we start with? I guess we can start with this question over here. Yeah. So now let's get rid of any rubbish that we have that is not needed for our question. There we go. So how much does a semicircular concrete arc weigh if all those conditions are met? So it is 120 centimeters across at the widest point. The inside gap has a diameter of 60, and it is 30 centimeters deep or thick. We're also told that concrete weighs 2.4 tons per cube meters. Now, the important part for merit style questions is that usually they are not necessarily much harder than achieve questions. But what is harder is that they are longer because you need to do more work. But from a measurement point of view, finding a volume, finding an area or surface area, they are identical in difficulty level. So let's have a look here, and I will tell you once you've achieved your achieved mark and your merit mark. So first of all, we're talking about concrete, we're talking about a structure, and of course, if we're filling it with concrete and we want to know weight, we need to know the volume. So what we're ideally here wanting is the volume of this shape. And now the question is, what kind of shape do we have? Well, and the first thing that we see here, it kind of looks like it's a disc, but we've only got half of it. Yeah, but I also see something a little bit different. I see that we have these lines here. They're all parallel. So what we actually have here is a prism. Yeah, remember if you cut it at one point, let's say you cut it with a knife. I can't really draw a knife very well, but it's more a sword or anything else. Yeah, there we go. If we cut it through this way, then it will all look exactly like this, which is the cross section. Yeah. So that was a terrible drawing, I have to admit. Okay, so we're going to be using our prism here. And the volume formula for the prism in your formula sheet will tell you it's the area of the cross section times by the length of the shape. Now, when we have a look at this picture, we didn't actually get any markings on it. We don't know how much this is or anything else. We have to get it from our question. And this is the step up between achieved and merit. So let's have a closer look here. We have 120 meters across the widest point. So the widest point would be from one side to the other side. That's the widest point. So from here all the way till here, we have 120 centimeters. So we're done with this part. We can tick that off. It says the inside gap has a diameter of 60. Well, where's the gap here? Well, this surely is this gap here. I'll make it a little bit further down. That's from here to here, right? Which is going to be 60. There we go. Next one done. What's the next part? So it says it's 30 centimeters deep, and they give you that it's thick. Yeah, so deep always means thick. So, well, where do we have that? That would be here on the side. Yeah, so that would be this part here. Make it a little bit bigger than the picture. Yeah, this is our 30 centimeters. Next part done. And now how much it weighs, we don't really need to know that for the volume formula. Yeah, so let's get back out in our question and let's have a look. It says the area of the cross section. Remember, if you cut it, the area kind of looks like this, right? Like this this kind of shape. That's the yellow part here. So if we look at this part here, that's the first part we need to find. Well, how do we do area? We first look at what shape it is, then we write down what formula it is. Well, what kind of shape do we have? We need to have a look at it a little bit closer because this shape here is not a normal 2D shape that we have, but if we extend it and look at it, it does look like shapes that we know. And I know I'm not the best artist here. These are supposed to be circles, not a Pokemon ball. So ignore that part. Now, if we now know it's circles, we need to have our formulas for our circle. So how do we get this outside part? Yeah, if we get it for a whole circle, afterwards we can just divide it by 2. Now it looks like a donut. I'm getting hungry. Gotta stay on topic. All right. So we have a larger circle on the outside and a small circle in the middle. And if we find the area of both, we can subtract the middle one to get the ring. So let's write this over here. Hopefully we have enough space. The area of the ring. So how do we do that? That's the area of the big circle minus the area. Let's do this one here of a small circle. So if we are focusing on this first, let's have a look how we can calculate this. Well, we know from our measurements that the middle part here in the middle was 60. That was the diameter of the inside one. And the widest point was 120. So knowing that, we can now solve this part of the question. We want to know the area of a circle. So what do we always do? We go to the formula sheet and we write down the formula. So it will tell you pi times r squared. And of course the same thing for the small circle. Just to make it a little bit easier for anyone to see later on, I'm going to make this a large R and this a small r, so that we know which one is the big circle and which one is the small circle. Okay, let's put the values in. What is the radius for the big circle? Well, we have the big diameter is 120. That's across from one side to the other through the midpoint. So that means that our radius is going to be half. So that's 60. And we have the diameter of the small circle is 60. So again, we have a small radius of half, which is 30. So we can put all of those into our equation, pi times 60 squared, and of course the minus pi times 30 squared. There we go. And we're going to get ourselves a calculator and just chuck those values in and we can figure out the answer all together. So shift pi, and then we're going to do times 60, and I'm too lazy to do a squared, so I'm just going to do this, and then minus pi again, times 30 times 30. There we go. And we don't want the number as a pi because it's a real situation. So our answer is going to be 8,482.3. Units, I think, were not given, but whatever it would be, units squared. We can put that in there. Units squared. Now, we have got the area of the whole ring, but if you remember, we wanted the area of the cross-section of it, which was just half of it. So that was this yellow part here. So all we're going to do is to get that is just half the amount that we've just calculated. And then we have ourselves the cross-section. So let's just do divide by 2. And again, we don't want the values in terms of pi. So we have, oh, wrong pen. There we go. We have 4,241.15, which was our area of the cross section. And then we just need to find the length of our shape, the length of the prism. Well, if we cut it, that is the cross section. How far it goes or how long it is, that is our length. So in this case, that should be h30. Okay, now we have those two numbers. We can multiply them together. And again, very easy. We've already got the 4,200 in the calculator. We're going to multiply that by 30 and get rid of the symbols. There we go. We have 127,234.5. Very annoying, so many digits, but that's all right. We have one decimal place rounding here. There we go. And of course, we have units squared. It does tell us it's centimeters. My bad. So it's going to be centimeters cubed. There we go. Not squared. Okay. Now, when we look at this question now, in this part here, calculating the volume, getting some calculations done in measurement, this will give you a full achieved, getting to this number. You can potentially get an achieved as well if you finish the question but have one minor mistake. Yeah, so for example, you might have forgotten to divide by 2, but you'd still do the whole question. Then you might still get an achieved even though you did the merit part. Okay, now the next part here tells us that we have 2.4 tons per cubic meter. So it tells us the weight for a certain amount. We know what the amount is, but the issue here is that we have it in cubic centimeters and not in cubic meters. And in order to calculate from cubic centimeters or cubic centimeters to cubic meters, we need to just change the units. So how do we change units here? Hopefully you guys all remember that 100 centimeters is equal to 1 meter. This is pretty standard, but we need this in order to find the answer. Also, now, if you don't know if you divide or if you multiply by the conversion, I always say that if the unit becomes bigger, the number has to become smaller. It's always the opposite. So that would mean you divide. On the other hand here, we want to have cubic meters here. So that's exactly what we had. The unit becomes bigger. So the number has to do the opposite. So the number has to become smaller. And how do we do that? We divide by the conversion rate. So we're going to divide both of these, by 100. Okay, so let's have a look at the calculator. And then there's a little thing that you guys need to remember for this. So we're going to divide by 100. Yeah, this would be the conversion from centimeters to meters, dividing it by 100. But the key here is we have cubic meters. So this number at the top tells you how often you have to do this conversion. So we have to divide by 100, not just once, not twice, but 3 times because the conversion is in volume, not in centimeters and not in area. So now we get as an answer 0.1. So 0.127. Maybe here we have 3 decimal places, just a little bit extra because the number is so small. So once we have this, now we can figure out how much weight we have, because now we know how many cubic meters we have. Each cubic meter has 2.4. So here, this is how much we've got. So we can just calculate the weight by calculating the volume times by this value here, 2.4, which is 0.127 times by 2.4. Okay, we've already got that number there. Go up a little bit, times by 2.4. So we get 0.31. Let's do 2 decimal places just because we had 3 already. We had 1 already. In the end, you just pick one that makes sense. And here, if the unit is tons, I think we don't need that many decimal places. So it's 0.3 tons, 310 kilograms heavy. Getting to this point here will give you the merit. And if you do the calculations here, you will get an achieved, even though you might have missed one little mistake. Okay. This one has some algebra in it. What else do we have? Yeah, I think both of these are pretty good. I mean, all of them are pretty good. This is a past exam style question, but it has a little bit more algebra in it. Maybe we'll return to it when we have done the algebra section. But all of these questions, you guys are free to pause and do yourselves, get some practice in, and then write your questions in the chat later on. Add the comments to the video if you're watching it after the live. And I always read all the comments, so I will help you guys out if you guys are stuck. Maybe we'll do this one here because it looks a little bit scarier. Okay, let's have a look. So again, when we read this one by one, we're going to just check what it says so we can make sense of it. A water tank in the shape of a pentagonal prism. So the pentagon is regular with each side measuring 5 meters and the prism is x meters long. So what does that mean? We can make ourselves a little note here on the side. We have a pentagon. It's regular. It's supposed to be regular. I think it looks somewhat regular. There we go. And it's a prism. So this is the base area. And from there, our lines kind of go like this, forming again another pentagon at the back. Can I draw that? Can I make that happen? There we go. Something like this. And like this. They should be all the same length. So let's see if that looks like a pentagon at the back. Yeah, kind of does. It's not terrible. There we go. So this is the shape that we're looking at. Now, we know it's regular. What does regular mean? Regular means that all of the side lengths are the same. So for this pentagon that we have in front, all of these sides here, the 5 sides, are all the same length. And they're all 5. And it says the prism is x meters long. So here, this part here is x, and all of these sides are 5. 5, 5, 5. There we go. Now, question A says, find an expression for the surface area of the prism in terms of x. Now, it does give you a hint here that the area of a regular pentagon is given by a formula, which is 1/4 times the square root of 5 times, open brackets, 5 plus 2 root 5, all multiplied by a squared. Now, if we're having a look at this formula, it looks very nasty, but Just because the question looks nasty or the equation looks nasty doesn't necessarily mean that it is difficult. We have already figured out what we have. So question A is telling us to find the surface area. And again, what do? We go back to the fundamentals and we check what is the surface area. How do we calculate that? That means each face of our shape needs to be added together. So we're going to have to add all of those together. If we're having a look at our shape over here, what kind of sides do we have? Well, we have 5 times rectangles. They're kind of over here, right? This one here. These are the sides. And what else do we have? We have 2 front pieces, well, 1 front piece and 1 back piece, but that's the pentagon piece. So we have 1 times a pentagon piece. Oh my God, that looks terrible. There we go. That's our pentagon. Sorry, 1 front and 1 back. There we go. And as long as we figure all of those out, we can just add them together. That is how we do surface area. That was our fundamental. So we're always going back straight to our fundamentals and solving our questions one step at a time. And hopefully it's still big enough for you guys to see. Now, let's figure out the rectangle first. Yeah, so we're going to have 5 times the area of a rectangle plus 2 times the area of, let's call it AP, the area of a pentagon. Okay, on the side over here, let's do the area of the rectangle first. Well, area of a rectangle, you guys should know, is base times height or width times length, whatever you guys prefer. So where is that? Well, we have this side here, which we know is x, and this side here is 5. So we can just multiply them together. 5 times x is 5x. And then what about the area of the pentagon? And that is where they have given you an equation, right? So let's have a look at the area of the pentagon. They have told you that the area of a pentagon is 1/4 times square root 5 open brackets 5 plus 2 root 5 close bracket. And this is the end of the square root, yeah? And then after that, we're multiplied by a squared. Now, a squared here is the side length. Well, if we have the side length here given to us, we know that it's 5, so let's replace it with that. And it is as easy as this. This is all you guys need to do. There's nothing else in here that you guys need to do besides the scary formula. And it doesn't really matter because we have a calculator. So let's put it in exactly how the question says. We have 1/4, and this is then multiplied by, but let's assume you forgot the multiplication button. That should still work. And then 5 open bracket 5 plus 2, and then another root 5 close bracket. And then we need to just move out of the square root and add a times 5 squared at the end. And we press enter, and it gives us 43 as the answer. Let's just round it to 0 decimal places so we don't have to worry about it too much. Yeah, so if we have 43 rounded, if that is the area for our pentagon, well, that's all we needed to know, right? We needed to know the rectangle and the pentagon. So we're going to go to the surface area is 5 times the area of a rectangle, which is 5x, and we're going to add 2 times the area of the pentagon, which we had is 43. Adding them together, let's have a look. We're going to get 5 times 5x, which is going to be 25x. And 2 times 43 is going to be 86. Now we can't add those together or change them at all because they are like terms. Well, they're not like terms, they're different like terms, what is what I meant to say. So 25x has an x and 86 does not. So this is our question already done. Yeah, we've got our surface area completed. Now for B, let's have a look. The tank needs to be painted on the outside only. If 1 liter of paint covers 8 square meters, write an expression for how many liters of paint is required. And again, this part in A would be an achieved just using measurement knowledge. Using that will give using that knowledge and go further, answer some questions in context is where your merit marks come in. So B is saying that it needs to be painted. We have already got the calculation here of what we have here, 25x plus 86. That is our surface area. And if we know that 8 square meters is covered by 1 liter, if we wanted to find how many liters we need, we just need to divide it by the 8 square meters. So we're going to get the amount of liters is 25x plus 86, all divided by 8 liters. And now we don't really need to change it in any way because we don't know what x is. We don't know what we need to do. However, for C, last question, we're given what x actually is. Let's have a look, make it a little bit smaller so we can fit C on the screen. So if the prism is 20 centimeters long and the paint is sold in 10-liter buckets costing $90 each, calculate the total cost of paint needed to cover the tank. So again, we're assuming we're just painting the outside. So we're going to have the liters, oh, excuse me, it's getting too close to the edge for me to be able to write. There we go. So we have the amount of liters is 25, and now we're told that x is 20. So we can just put that into our formula. That's why we have a formula, and we can just chuck that in the calculator. No work really needed here. So we're going to have a, oops. Can I go back? Delete. All right, we have to start over. There we go. We have a fraction 25 times 20 plus 86 on the numerator, and the denominator here, go down, yep, there we go, is 8. Again, we don't want a fraction. We're going to go put this as a real number, which is going to be 73.25. Yeah, so what does this number give us? That is the number of liters. And what does the question tell us? It says we have 10 liters in each bucket. So how many buckets do we need in order to make this happen? Well, to get to 73 with a 10-liter bucket, we can just divide it by 3. So we have the buckets. Let's make a little line over here. So we have the buckets. It's 73.25 divided by 10, which is 7.325. So we need 7.3 buckets. So that's about 7 buckets and a third. But how do we buy them? Well, we have to buy them in buckets. So we can't just get a third of a bucket at a shop. So the answer is going to be 8 buckets. Yeah, we need to get extra here, and we're going to use a little bit less or a little bit more of paint anyway, so that's fine. But we always have to round up in these questions. So there we go. We have it, 8 buckets, and getting to this here will give us a merit. Okay, now we've done a few achieved and merit questions. There's a few more questions for you to do, so I'll blend them in as we speak here, so you guys can try them on your own. Try and pause them, give it a go, and then let me know in the comments later on if you guys find these easy or difficult. And I think for the excellence style questions, I'm going to make a separate video where we just focus on the excellence questions for this exam. Is there anyone interested in seeing the excellence questions in this stream, or did you guys want to do another merit question? Kind of wait a little bit and have a look what everyone wants. And again, for you guys, if you guys are viewing this later on the recording, make sure that you guys give me a like. That really helps me out. This is just the beginning of my channel, so there's going to be a lot of tutorials, a lot of help for you guys later on. So it doesn't look like anyone really has any preferences. Yeah, okay, sounds looks like another merit question. Okay, let's do that. Okay, so let's have a look at this question here. This is a past exam question as well, and it has a little bit of algebra in it. In a triangle ABC, the length of the side AB is y centimeters. The side AC is k centimeters longer than the side AB, where k is bigger than 2. Okay, so far already we have so much information we can't keep track of it. So what we're going to do is we're going to start one by one, sentence by sentence, and make sense of it in a little diagram. So it says we have a triangle ABC. So let's just draw a triangle. There we go. And name our sides ABC. Okay, now we understand this part here. The next part is that the length AB is y centimeters long. So that's an easy one. AB is here at the bottom. So let's put that as y. Now the next part says the side AC, which is from here to here, is k centimeters longer. So it's not k, it is longer by that much compared to the side AB. If the side AB is y centimeters and one of the other sides is k longer, that means it is y plus k centimeters long. So this is y plus k over here. And we know that k is bigger than 2. So we're given information about k that is greater or equal to, which is kind of like a restriction. Now this restriction, when they tell you what something is, it's a positive number or it's less than 4 or something like this. This is always for the end. Yeah. So you guys can ignore this while you guys do the question for now. Let's have a look at the side BC. It's 4 centimeters shorter than AC. Shorter means less. So y is AB. And if it's shorter than that, we can do -4. And now, just like that, we've transformed all of that text into a question with a diagram that we can work with. So, last part, it says the perimeter of this triangle is 5 times the length AB. Well, first of all, we note it says perimeter. Well, that means we already know we're going to be working out P, and it also gives us what it is. So it tells us that the perimeter is 5 times the length of AB. So it's 5 times, well, and the length AB, we can quickly check that in our picture, is y. So it's 5 times y, which is just 5y. Okay, it's asking us now to find the perimeter of the triangle, giving your answer in terms of k. And again, if we have numbers, then we can substitute things in. We can get our answer in the calculator and find the final answer. But again, this in terms of part, yeah, make sure that you guys really know what this means, because they love this in exams. I see this in multiple times in algebra exams and in multiple questions in the mathematical reasoning exam. At least in the past 2 years. Hopefully they're not changing too much. They've just changed the whole level 1. So please keep things a little bit, the same for our students. Okay, so in terms of, remember that means we want to find a formula for our perimeter. Yeah, find P, find the perimeter. And in terms of K means we're allowed K's in the answer. Okay, now I'm going to just start and we're going to write down perimeter, because we've been given something about a perimeter. That probably means we always have to work out how it's usually made. So where we're going to start, let's start at A and go over to C. Yeah, that's going to be y plus k. And then how do we do perimeter? We add all of the sides together. So the next one is y minus 4. So we're going to get y minus 4. and the last time is y. And what do we do with each of those? We add them, and I prefer if you guys put them all in brackets. If you have put them in brackets here, it is easier not to forget sometimes when you have to multiply things or work things out with expanding. But here, because they're just plussed, there's nothing else, there's no negatives in front of the brackets, we can leave them out. So what do we get for our perimeter here? Well, there's 3 y's, and we have k plus a k, and we have a minus 4. Okay, so this is everything that we've got for our perimeter from the question itself here. It wants us to write this perimeter in terms of k. Well, how are we going to do that? We have an equation here. Does that even make sense? So we have perimeter is 5y. That's this part over here. So what do they even want? Do they want y in terms of k? Is that what the question wants? I'll have to double check if this is a typo. This is telling us to find the perimeter, but the perimeter is already given just in a formula of y and k. There's no way for us to remove the y's. I will double check with the question and probably post it in the comments afterwards, but I'm pretty sure the question here wants to find y, the side AB, giving it in terms of k. We could maybe do that. Here we have an equation with y and k, which we can use algebra to solve for y. I guess we could make a formula for y and then substitute it back in for the perimeter. My bad. Yeah, I guess we can do that. It's a little bit extra work. More algebra than anything else. Let's try not to do too much algebra in the topic today. So how do we rearrange this? Well, we can do minus 3y on both sides here, which will give us 2y is k minus 4. And what's next? So we want to know the perimeter. It's actually a very sneaky question. So we want to know the perimeter, which is 5 times y. So if we can work out from this relationship here, from this equation, what y is, we can substitute it back into the top. So what do we need to do? We can divide by both sides by 2, which will give us y is k minus 4 divided by 2. And now what can we do? Now we know what y is, which is this part here, and we can substitute that back into the y here at the top. So let's do that. I'll probably write it in green because that is not part of the first part. So we're going to get 5. And every time we substitute, again, we need brackets, yeah? Times k minus 4 over 2. And now again here, 5 times brackets is the same as 5 times a fraction, so we can leave it. That's perfectly fine. We know we don't need that brackets anymore, but it's really good to start with having them so that we can answer the questions without missing negatives or multiplication. How do we multiply a number times a fraction? That is the number times the numerator. So we're going to get 5 times k minus 4 over 2. And here we do need brackets. Why is that? Because every time when we have fractions, the numerator and the denominator are treated as if they have brackets around it. Because technically what this is saying, I can write it over here on the side, k minus 4 over 2 is the same thing actually as k minus 4 first, then divided by 2. Because we always calculate the numerator and the denominator one by one, then we do the divided by calculation. Mathematicians are really lazy, so that's why we kind of leave those brackets away. But you can always remember on the numerator and the denominator around a fraction is usually brackets. You have to do those first. So any algebraic moves, any expression changes, you need to remember brackets. But we'll cover that very well in the algebra topic. So let's leave it as that for now. Again, this one here should probably give you the full mark, but you can finish this question up by simplifying it, expanding the brackets in the top. But because this is not the algebra topic, we're going to leave it as that to give the merit mark. Actually, a very good question. Now where I think about it, it was not straightforward where you see already what the answer is going to be just when you read it. So you need to kind of just trust what you're doing. We knew we had to calculate the perimeter, so we kind of went through that. And as we were going, well, things actually puzzled together. Our pieces got together. And yeah, wonderful. Awesome. Okay. In that sense, I will do a separate video with the excellence questions by themselves. And thank you very much for everyone in the comments, especially requesting the numeracy practice. Yeah. So what I will do is I will upload a video with some past questions and some questions that I'm making myself up. Yeah. So you guys can go through those. Maybe it would be good to do a past exam question, and then each question that we do, I'll change that question up a little bit and you guys can do a similar question for practice. But yeah, for that, I'll see you guys in the next stream next week. Again, every week, level 1, 3 p.m. to 5 p.m. on Sundays. We're going to finish a little bit early today because it's no point doing the excellence questions if we just have 10 minutes. So I will post those as a video, and